Let's enjoy. We love to have the picture of this organic chem. We want to see everything. We want to see everything. We want to be able to just do all these reactions without bothering. Now we are looking at ethers. We have done ethers right after alcohols because ethers are so linked to alcohols because they are only made from alcohols. Okay, ethers are made from alcohols, either the alcohol or phenol. That is where ethers come from. So now let's put the preparation reaction. This is so easy because we know that ethers come from alcohols. And now the preparation reaction we'll do is going to be first. We are just going to be coming from alcohols, but there are two ways to do it. The first one is going to be the Williamson synthesis. Now, the Williamson synthesis is like, we know that you be having your ether. You first start with your alcohol, right? You have your alcohol, then you must convert it to an alkoxide. Now, it all depends with, is your alcohol like a phenol, or is it just a straight chain alcohol or some other alcohol which is not a phenol? So if it's just because we saw the ways that we can convert our alcohols to alkoxides. Remember, we had it here. Let me take you here. We had either for these type of alcohols which are cyclic or whatever, but not having a benzene ring, okay? You can have a cyclic thing like this. You can have a cyclic alcohol like that. OH, and we can be able to convert it to an alkoxide. And here are the ways we know that to convert an alcohol to an alkoxide, we can add a metal or a metal hydride, because an alcohol is a weak acid. It acts like a weak acid. So we can add a metal to it, and we'll get a salt and hydrogen. We can add this metal hydroxide, which is a base, okay? We can get another salt and hydrogen again. We can add, for phenol though, we add a metal and this metal hydroxide. Here, this was a metal hydride. This is a metal hydroxide. And we'll still get your salt, the alkoxide. This is now a phenoxide, yes. But it's still O and Na minus. That's the same thing we do here in Williamson synthesis. We first have to make a metal alkoxide. So you can add either a metal or you can add a metal hydride, okay? Don't be limited to one thing. So it's so easy. We can add, let's put our alcohol maybe. C2H5OH, okay? And then we are going to add 2 moles of sodium. Now what it's just going to do is it's going to make us have 2 moles of C2H5, then O minus Na plus. Okay, what it simply does is it removes the H and then it puts the Na, okay? Then what would we get? The H will come out and become a hydrogen at the end. Okay, we can do that. We can add sodium metal. If we don't want to add sodium metal, we can add a metal hydride or whatever, and we'll still just have to balance. These twos were just to balance because we're adding a metal itself, and we want to get hydrogen as an H2 at the end. Okay, this is the step 1 of Williamson synthesis, is to make an alkoxide. Okay, step 1, make an alkoxide. So make an alkoxide. Then the step 2 now is then convert it to an ether by adding a alkyl, what is it? What do you call it? By adding an alkyl halide, right? And by adding an alkyl halide, which is like a halogenoalkane, okay? A halogenoalkane, that's the name I was looking for. Halogenoalkane or alkyl halide. That is the step 2. So step 2 is just add alkyl halide to what? To your alkoxide, okay? Because we know what's going to happen, so I'm just going to have my 2, let's just say your C2H5, then O minus Na plus. Then what am I going to get? This is just an example. I'm going to add an alkyl halide. Just like to say I'll add a CH3Cl, okay? An alkyl halide is just a halogenoalkane. Like you put a halogen, which is group 7, in your carbons and hydrogens, okay? And now what am I going to get if I do that? Well, if you do that, what's going to happen is this Na, we know its behavior. It loves group 7 more than anything. So it's going to take the chlorine and you end up having, let's just put it like C2H5. Then you have the O. Then after the O, you have a CH3 come. Then what happens? This Na takes the Cl and it'll be NaCl. That's just what happens. So here we have added our alkyl halide and I've put an example and this is what happens. Okay, so this is Williamson synthesis. So if we put it in general form, we'll be just saying in step 1 for Williamson synthesis, these are just the ways to make an ether. Ether is made, number one, by Williamson in synthesis, and then number two, by adding sulfuric acid to your alcohol. So here we can just say step one was we had ROH, right? Which is your alcohol. What do? Add a metal or a metal hydride. And what are you going to get? 2R, then O minus Na plus, and hydrogen, okay? Then what is going to happen again? If you want to add it as a metal hydride, it'll be just NaH, but then you don't have to put the two moles. Okay, you don't have to put that because H2 will come from this H and this H. Okay, right. So now this is what happens, and then you can say now in step 2, you can then bring your alkyl halide, which is going to be RO minus Na plus. We now add some carbon. Remember, R just represents carbons. Okay, and there is a chlorine there. Okay. We have carbons and whatever, and they bond. It's carbons and hydrogens, and they are bonded to group 7, which is a chlorine or a bromine or an whatever. And then what happens is you're going to end up having ROR prime. This is your ether. And then we have this Na and the X, so we say plus NaX. That is what happens in Williamson synthesis. We can have Williamson synthesis again for, your phenols, okay? It can happen and it will make just an aryl ether. So you can have it like this. We can have it the same thing, and we have an OH, and this is a benzene ring, okay? Remember what we add. We can add for our benzene ring. Either we can add a metal or we can add NaOH. So it's up to you. You can add NaOH, which is a strong base. And what are you going to get? What am I going to get? I'm just going to get an alkoxide. How do you get your alkoxide? Simple. So this was an OH. So you can have it like this, and it's going to be like this, like this, like this. Then here we'll have an O minus Na plus. Okay? And what is that going to be? This is our step 1. Remember that this is our step 1 where we'll get our alkoxide. And what happens? This H joins with the OH, and you'll be getting plus H2O. Then now in step 2 we can now do our step 2 where we take the alkoxide like this one. And remember what we are trying to make. So our alkoxide is O minus Na plus. We can just come and add it to a alkyl halide. We bring an alkyl halide again. And this alkyl halide, we know Na, once he sees group 7, he's like, oh my God, let me run to him. And you leave this O, the R prime will go. So we have it as something like this. Like this, we have it, our benzene ring here. And then this becomes or then R prime. Okay, it's just going to continue. Then now this would be NaX at the end. That is what happens. This is Williamson synthesis for your phenols. Okay, then now this is Williamson synthesis is done. Then the last way to make, which is method number 2, to make your ethers is going to be the sulfuric acid. Okay, we say it is the alcohol sulfuric acid method, but we know that for both we are still studying at alcohols. Okay, alcohol sulfuric acid method, but we know that we still are doing alcohols for both of them. So look, here we started with what? An alcohol again, but it was a 2-step process. Here we had our step 1, it's Williamson synthesis, okay? Then our step 2. In step 2, what do we add? This is a phenoxide and an alkyl halide. In step 2 for here, what did we add? An alkoxide and an alkyl halide. Okay, we started with an alcohol, we converted it to an alkoxide, then we added to the alkyl halide. Now here we are. What do we do here for alcohol sulfuric acid method? Well, you must remember that if I had my alcohol, let's just put even ethanol, C2H5OH, we love this guy, or we can say C3H8 H7, sorry, 7 is 2 plus 1. It's 2n plus 1. H7OH. Now, what can we do here? Well, we have this guy, and what am I going to add? Look, you're going to have your sulfuric acid, H2SO4, right? And you are going to heat. Now, remember that if I heat at 180 degrees Celsius, this thing I'm going to get, usually we like to put H2SO4 on the arrow, okay? H2SO4, and we put 180 degrees Celsius. If I do this, 180 degrees Celsius is 453 kelvins, okay? Sometimes you see them say 443 kelvins, whatever. If you heat this, you are going to get an alkene, okay? You're going to get an alkene. But if you heat it to, instead of 453, if you heat it to 413 kelvins, you are going to get an ether, sorry. But you need to have two of the alcohols. Then they're going to come together. So what you end up having is C3H7 or, okay, and then instead of the H, you have another C3H7. This is then what happens, and this becomes your ether, okay? And what would happen? Would release an H2O, because we are going to remove two hydrogens and oxygen from the second thing. So if we were to put it, and this, you should know that this is C3H7 or C3H7. This is called a symmetric ether. You make an ether which is the same on both sides. We call it a symmetric ether. The one we were making above here is not a symmetric ether. This is a symmetric ether because what is on the left and what is on the right of your O is going to be exactly the same. So this is what happens. This is what happens. Can you see it? Look, this is the alcohol sulfuric acid method. The only thing that changes is the temperature. And then you're going to get an ether. Okay? You just reduce it to something close to 400. Remember, when it's close to 400, it's for the ether. Then when it's high, like 453, 443, it'll be going to an alkene. Same thing. Okay? And you'll be done with the preparation reactions. Now you'd need to go to the reactions themselves. And that's what we're going to be talking about now in the next video. Goodbye for now.